For this physics extra credit video, we discussed special relativity. So first, we figured out that there were two types of exposition, the what and the why how. We used linear algebra, which discusses matrices, to express this theory of relativity. So first, we looked at the linear algebra scaffold. We looked at the vector space and then the linear transformation, so what preserves versus the structure. Then we looked at matrix multiplication to decompose it. So once we decomposed it, we looked at the axioms of special relativity. So there are 3 points to this. 1, the laws of physics are equally valid in all the frames of reference that we observe. 2, the speed of light c is the same for all observers regardless of the motion of the source of the receiver. And 3, the speed of the propagated wave does not depend on the speed of its source. So we would look at the inertial frames, which were communicated in only one way. Now we go from perceived reality to the mathematical operations. So we took the ordered pairs from the x-plane and we used them to add stretch and other things. So there are 5 properties of initial frames. 1 is that all frames are identical at rest. 2 is that observers within any frame are fixed. 3, communication between frames only via perpendicular line of sight. 4, all ordered pairs of the frames are linked because they're synchronized at 0. And 5, the speeds have to be symmetric. So the moving clock slowed down while the moving objects shrinked in the direction of motion. And the consequence of this was the accommodating universe. So there are 2 paradoxes that we're going to look at to kind of describe this. One is the bug rivet paradox, which has to do with the frames of the plates in motion. Something we had looked at during the talk was that a rivet in motion and that the frames of the rivet changed while the plates were in motion. When the rivet hit the plate, the bug was caught in that one frame, but not in the other frame due to gravity force and the tension force. And the twin paradox we'll describe in more detail with this. So this describes one of the paradoxes, the twin paradox. At time 0, one twin stays on Earth and the other twin starts his travel into space at a constant speed of 0.8 times c. After 25 Earth years, the traveling twin instantly reverses direction. After another 25 Earth years, the traveling twin reaches Earth and has aged only 30 years, while his Earthbound twin has aged 50 years. At the journey's midpoint, the outgoing spaceship time is 15 years, while only 9 Earth years have passed. Once the twin instantly moves to the incoming spaceship, he resets his clock to 15 years, but to his surprise, he sees that the Earth clock reading has jumped from 9 years to 41 years. General relativity explains this jump as follows. The huge acceleration of the transfer causes the spaceship twin to see his own clock speed up by 32 years. In this sense, the forces of the spaceship transfer, however brief in time, thrusts the traveling twin 32 years into Earth's future. So I hope based on that little animation you can better understand some of the physics that we were taught. So we then looked at some different diagrams, including the Galilean space-time diagram, the swiveled line theorem diagram, and the Minkowski diagram to help further explain these concepts. We were also told, as a little fun fact, that we could measure c, the speed of light, at our own home. We could cook bread in the microwave and see hot spots. We would use the distance between those hot spots to find the frequency, which would then equal c, so it was exciting to see some of those things. So some things that I learned that I didn't really know before coming in were that you could relate the schema of linear algebra to express the theory of relativity. I thought that was something that was really cool, and it sparked my curiosity because it explained how you can go from mathematical operations to perceived reality. So it was very exciting to see that. Thank you for watching my video.